Now we consider the following matrix A, which has zeros almost everywhere except when on this first row and first column position, and on the first row and the second column position. Okay, if we note the elements of this matrix by A, I, J, with i's going from some part of n, and j is into some part of n, but we call them, let's call it n. Okay, we have n elements. That means this is the set from 1 to n. Okay, and here we see that a11 is 1 and a12 is 1. All the other aij are zeros. Okay, we want to compute a squared. Okay, so to compute a squared, we just use our way of multiplying matrices. Okay, here we're gonna write a again, 1 1 0 0 0 0, and here 1 and zeros everywhere. The same thing here, we have zeros everywhere except for the first row when we have these two elements non-zero. Okay, so we're gonna use our the rules for multiplication, okay, to get the result that we need. All we need to do is to be careful. Okay, here we're gonna apply the multiplication here. So we're gonna multiply the first row by the first column, component wise, element by element. That means 1 is gonna be times 1 plus 1 times 0 plus 0 times 0. Okay, and therefore we have only 1. Next, we do the same thing for the second column. We obtain 1 and zeros everywhere. For this one here, the second column, second row, it's zeros, and if we multiply the first column, we get 0. If we multiply the second column, we get 0, and etc. Okay, and therefore, since all these ones are zeros, we will have zeros everywhere. Okay, and this means that in our case now, we obtain the same matrix that we started with. Okay, that means this is a squared. This is a squared. It's a times itself. That means we get a when we multiply, and this proves that a squared is just a. Okay, before we end this video, what's a sub an? Not sub n, a to the power n. N is in n. How does it look like? Okay, you can compute that, or you can say it in the comment section. Okay, thank you very much.